Hey everyone, my name is Courtney. Welcome to our Rockin video. This video will be a bit different because we will not just be focusing on one rock type, but we'll be discussing and explaining the properties of each of the three rock types and then which characteristics of each type we use to identify them. This is kind of exciting because now you can put my name and my voice with an actual person. First off, I want to introduce my very special assistant, Emmy, who will be helping me show the different examples of each type of rock for this video. So before we get started, let's quickly review the three rock types and ways that are used to identify them. First are igneous rocks, which are identified using texture and composition. Next are sedimentary rocks, which are clastic or chemical. And finally, metamorphic rocks, which are pre-existing rocks that are substantially changed physically or chemically. Let's get started with our first type, igneous. Igneous rocks are the only rocks that form from the cooling and solidifying of what was once molten or in a liquid state. When magma or lava cools and solidifies, this forms igneous rocks. Igneous rocks are identified by their texture, which identifies the rock's physical characteristics such as grain size, and determines how the magma or lava cooled and solidified. They are also identified by their composition. The composition of igneous rocks identifies the rock's specific mineralogy and chemical composition, which determines the temperature and pressure conditions under which the magma or lava originated, cooled, and solidified. I have a few examples to show you to demonstrate their identifying characteristics. The first rock is granite. Its composition is felsic, meaning it contains mostly light-colored minerals and is high in silica, but also does have small amounts of mafic or dark-colored minerals. Its texture is phaneritic, meaning the individual crystals are visible to our unaided eyes. This rock was magma that cooled slowly in the crust, allowing the crystals to grow large enough to be visible to the naked eye. Our next example is basalt. It looks different right away as it is mafic, meaning that it contains mostly dark-colored minerals as it is high in iron and magnesium, but low in light-colored felsic minerals. This texture is aphanitic because the grains are too small to be seen with our unaided eyes. It is also vesicular because it contains holes, which are called vesicles, which come from gas bubbles. This rock was lava that cooled quickly on the surface, giving minerals very little opportunity to grow. The last igneous rock sample we have is pumice. This rock is felsic and was cooled quickly at the surface, but it displays a unique texture referred to as frothy, which means it is full of vesicles. In fact, because there are so many vesicles, pumice will actually float in water. We're going to demonstrate that with this glass of water. That's pretty incredible, huh?
Yes.
Hopefully that will give you a better understanding of the types of igneous rocks. Now let's move on to sedimentary rocks. There are two types of sedimentary rocks. The first is clastic, also called detrital, and are made from pre-existing sediment pieces that come from weathered bedrock that is compacted and cemented. Clastic rocks are classified by grain shape, grain size, and sorting. The second type is chemical, which are precipitated from water saturated with dissolved minerals. Chemical rocks are classified mainly by the composition of minerals in the rock. Let's start with our first sedimentary rock example. Our first example is conglomerate, which is a detrital-clastic sedimentary rock. This rock has round fragments and pebbles which are easily visible to our unaided eyes. It is also poorly sorted, which means it has grains of varying sizes in a sandy matrix, which is fine-grained. This type of rock would form in the center along the banks of a riverbed in the mountains or along a rocky coast with high wave action. The next example we have is travertine, which is called a chemical sedimentary rock. As you can see, it has layers. It also appears to have crystals. And if we take this vinegar and put a few drops on it, it will fizz. This type of rock would most likely form at a hot spring or a limestone cave. So our last example is a fun one. This is a fossiliferous limestone and is a biochemical organic clastic sedimentary rock. This rock is a type of limestone and has a light colored hue, possibly from shells, and what makes it interesting is that it also contains visible fossils which can be seen with the naked eye. Because of this, it would most likely form in a tropical beach environment or in deep sea deposits of fossils. That should explain a bit more about sedimentary rocks. Now onto our last group, metamorphic rocks. Metamorphic rocks form when solid rock changes in composition and or texture without the mineral crystals melting. These metamorphic processes take place deep underground inside the Earth's crust when the parent rock, also called protolith, has its chemistry mildly changed by increased temperature or heat, confining pressure, and or chemically reactive fluids. The texture is changed by heat, confining pressure, and a pressure called directed stress. The two types of textures are foliated, which is identifiable by its layers of minerals lined up in planes, which sometimes resemble the stacked pages of a book. Lineation occurs when the minerals are longer in one direction. The other texture is non-foliated, which is when there are no lineations, foliations, or other alignments of mineral grains, and is typically composed of one mineral where crystals grow together but do not have a preferred direction. Let's start with an example of a non-foliated metamorphic rock. This is marble. It has a granular crystalline texture, and you can see the calcite crystals. It is one color, white, and there is no layer texture or alignment of the grains. Our next example is called gneiss. This is an example of a foliated metamorphic rock. It is coarse-grained, crystalline, and has an obvious banding of light and dark minerals, which can be seen very clearly. So one of our favorite hiking trails here in Tucson is Montana Canyon, which has very large canyon walls and fallen boulder pieces of nice rock with the beautiful foliated layers that you can see right here. Thank you guys so much for taking the time to join us on this journey through igneous, sedimentary, and metamorphic rocks. We hope it was informative, a bit entertaining, and we also hope that you enjoyed it. So we appreciate it. Thanks again and enjoy your day.